three times, there must be some discontinuity in phase when we shift from 1 to 0, from 0 to 1, again 1 to 0, and 0 to 1, and again 0. So in this case, non-coherent, there must be discontinuity in the phase when a signal element ends and another signal element starts. Or you may say when one data element ends and another data element starts. Whereas in inverse to this or reverse to this, coherent BFSK can be implemented with the help of a voltage controlled oscillator, and in this case there is no discontinuity or no change in phase when we shift from one bit level to the another bit level. Now let us talk about the multi-level FSK. On the next slide, we will talk about the implementation, coherent, non-coherent implementation. But let us talk about the multi-level FSK first. We have discussed the binary FSK. Means the two levels, two frequencies should represent the two types of bit. Suppose we have 3 bit at a time, 4 bit at a time, and so on. If we have 1 bit at a time, so one frequency is sufficient to represent 1 bit at a time. If we have 2 bits at a time, then we must have 2 raised to power 2 frequencies to represent those bits. Because you know the 2 bit means 0 and 1, and there are 4 possible combinations of in the digital electronics of your lower semester. You must have studied about the adder, subtractor, etc. So these 2 bit has 4 possible combinations: 0, 0, 0, 1, 1, 0, and 1, 1. So there must be 4 different frequencies to represent 2 bits at a time. Similarly, if there are 3 bits at a time, so we require 8 frequencies. If there are 4 bits at a time, then we require 16 frequencies to represent these bit streams or data streams. Plus, there should also have some gap between these frequencies, which is called as twice delta f, and these frequencies are twice delta f apart from one another. However, this gap is not very large, it is small. So, multi-level FSK operates in this fashion. Binary FSK operates in a fashion that we represent 0 and 1, 2 separate bits by 2 separate frequencies. One will represent the high level, 1. A lower frequency will represent the lower level, that is 0. So if one wants to send 2 bits at a time, then we require 4 frequencies. 3 bits at a time, we require 8 frequencies. 4 bits at a time, we require 16 frequencies. So bandwidth for this case is also 1 plus d into s. D is again a factor which lies between 0 and 1. L is the number of levels. Twice delta f is the gap between the frequencies or frequencies apart. Now let us talk about the implementation of binary FSK. So in binary FSK, can you see the cursor moving on the screen?
Yes, sir.
Okay. So binary FSK, we require a signal called as unipolar NRZ. It is a digital signal. We have already studied the digital data and digital signals. We have studied that there are the schemes in which we are having data as a voltage representing in unipolar when x-axis is not crossed, when x-axis is crossed polar, and other than that, when we have a long sequence of zeros and ones, we can replace them with the B8, ZS, or HDB 3 coding schemes. So since we are talking about the digital to analog coding scheme, so we have a data which is represented in the form of a unipolar NRZ coding scheme, which is a digital coding scheme. So this data is in the digital coding scheme unipolar NRZ, which is 10110. Here the data element or signal element does not cross the x-axis. Then we know the process of modulation. In modulation process, we need a modulating signal. We need a carrier wave. After that, the modulating signal is superimposed or added or multiplied in a modulator, and we get a modulating signal. So in modulating signal, one frequency component which is higher will represent a 1 bit. The another signal element which is having lower frequency will represent the lower bit, and so on. Higher frequency represent 1, again higher frequency represent 1, and in the end the lower frequency component represents a 0 bit. Now how to implement this? To control this flow of frequency, higher and low frequency for 1 bit and the 0 bit, we have a voltage controlled oscillator. So this voltage controlled oscillator controls the frequency and correspondingly what it represents. So at the input, we will have a digital signal which is NRZ. This signal is fed into a voltage controlled oscillator. Since it is an oscillator, so it is capable of producing oscillating frequencies, and these oscillating frequencies are nothing but the frequencies of high frequency. So when this digital signal NRZ polar scheme is superimposed upon carrier which is generated by the oscillator, then at the end we get a modulated wave which has the regions of low frequency as well as regions of high frequency. So this arrow mark represents the region of low frequency, and these arrow marks represent the region of high frequency. So we have two zeros which are represented by the low frequency, and we have three ones in the data which are represented by the high frequency. So you can see how this binary FSK works. However, we can also have multi-level frequency shift keying as well. Now the next topic of our syllabus is the phase shift keying. As the name suggests, now the third characteristic property of the carrier wave should vary, and this third property is the phase, and amplitude and frequency now will remain the same. So we will be able to represent a binary BSK when there is no phase change, that is 0, and when a phase change is 180 degree, it will represent another bit. So how it represents? Let us say again we have a coding scheme which is digital coding scheme, that is unipolar NRZ. Its bit rate is 5, baud rate is 5, that is 5 signal elements and 5 data elements. That's why its ratio R is equal to 1. Signal element is equal to data element. Its bandwidth is equal to 1 plus D into S. Why 1 plus D into S can? Why the twice delta F is not here present? Common sense. Am I audible? Anybody answer? Common sense है भाई. Okay, let me answer. The common sense is that this method is based upon phase shift keying. So there is change only in the phase. However, the amplitude and frequency should remain constant. So here the signal element has nothing to do with the frequency. So all signal elements should have same frequency. So if the frequency is same, there is no frequency apart. The twice delta F function becomes 0, and we in bandwidth we have only 1 plus D into S. So in phase shift keying, the data element has nothing to do with the amplitude or frequency. It has to do only with the phase. So one signal element will represent, if it is 0 phase, and if it is 180 degree, it will represent another bit. You can see here is a phase change when a bit changes from 1 to 0 and 0 to 1. 180-degree phase shift is 1, 0-degree phase shift represents a 0. There is no phase change when we have another 1, and there is again a phase change when we get a 0. So this is very clear from this diagram that how a bit stream of 10110 of unipolar NRZ is represented by phase shift keying, and there is constant frequency and amplitude. That's why the bandwidth is equal to 1 plus ds, and twice delta for f function is 0 for phase shift keying. Now how to implement this? To implement this, let us consider a polar NRZ. In polar NRZ, we know a bit is represented by one positive voltage level, another bit is represented by a negative voltage level. And why it is called as polar NRZ, we have already discussed it, that it crosses the x-axis. It goes from positive to 0, 0 to negative, and from negative to 0, 0 to positive. That's why it is called as polar NRZ. In case of frequency shift keying, we talked about the unipolar NRZ. The data element does not crosses the x-axis, whereas in case of phase shift keying, we take polar NRZ coding scheme. This is a polar NRZ coding scheme. This is a modulating signal. Oscillator will generate carrier signal of high frequency. When modulating signal is superimposed upon the carrier, we obtain a modulated wave, and modulated wave has the phase changes whenever a data element changes from 1 to 0 and 0 to 1. One data element has a 180-degree phase shift, and 0 data element has 0 phase shift. That is, it starts from 0, and one data element starts from opposite 180 degree. And how it is implemented? We supply a polar NRZ digital data coding scheme, and that polar NRZ is fed into the modulator or the multiplier. Carrier frequency is generated by the oscillator, which is high frequency, and after this, the process of implementation of binary frequency shift keying, phase shift keying is over, and we represent a bit stream of 10110 by this type of modulating signal. So from my side now, the digital data and digital signal, digital data and analog signal techniques are over. Now we